Hello, welcome. My name's Phil Winder. I'm the CEO of Winder.ai. We're an AI agency and we help businesses implement their AI strategies and ambitions. In this presentation, I want to talk about the applications of retrieval-augmented generation. So quick admin before we get started. So as usual, if you've got any questions, I'll be happy to answer them. Please post a comment in the platform that you're currently watching this in, and I'll get to it as I get through the video. There was a little problem with LinkedIn earlier on, so apologies if there's any issues with that. The event page just was 500ing, so don't know what's going on there. The video will always be available on our blog a couple of days after. Anything else? Yeah, just another thing just before we get started. Today's talk about is the applications of RAG. If you have not viewed one of our presentations before, then I recommend that you go back and look at some of the previous videos that we've done, previous webinars, and they talk a bit more about what RAG is and how it's useful. So there's a little bit more context there. And as always, I will create a blog post a couple of days later with all the links and extra information and stuff that's just maybe not in the slides. Okay, so let's crack on. So this presentation has split into 3 sections. It's not very long, should only be about 20-25 minutes long. I'm going to look at the industries in which RAG is currently being used with some actual demonstrable examples of that. Based upon a literature review I did recently. Again, I'm going to post the links to all of that later. Then I'm going to talk about how I've pulled out a broad range of tasks that RAG is particularly suited for based upon all of those industrial use cases. And then finally, I just want to comment on some of the themes and challenges that many of the authors of these various implementations suffered from as a way of kind of highlighting what some of the challenges might be for you. So let's dig into the industries. So I've got a couple of slides here which try to take a look at an example from as many different industries as I could find. Hopefully there's one there that will match whatever your industry you're in. And we're going to start with finance. Finance is quite a big user of LLMs in the sense that they are attempting to leverage it to perform a variety of tasks. However, they're a bit more regulated than most other companies. So it might seem like they're a bit slower to use to leverage them more effectively from the outset, but they'll get there eventually. And in this particular use case, they were using RAG to retrieve information from financial sources of data and present the results in a QA chatbot-like feature. On the right, we've got an example from the legal industry. This is a similar kind of idea again. They're trying to ingest and incorporate knowledge from all of the wide variety of legal sources that can be used in the profession and leverage that to answer questions for legal research in particular. So that's the phase of the legal process where they're trying to investigate legal statutes and laws and things like that. We've also got examples from the medical profession and healthcare. In medicine, I've seen examples of people using various public data sets to help ground LLMs to basically hallucinate less by incorporating external data sources from real medical data sets. This is an example of actually optimizing an LLM specifically for medical use cases based upon some of these public data sets. And on the right, we've got a really nice example of the use in healthcare. And the reason why it's a bit different this time is that this particular example focuses more on the extraction of that information, the retrieval from SQL databases, from relational databases. So previously, many of the other examples have been pulling information from a repository of documents. Here's a use case where we're actually trying to pull the information from a repository in the sense of a database repository. Again, on the left, I've got a quick example from slightly more engineering side of things. There is an example here for mobile. Well, it was telecommunications example here, really, where somebody was using the retrieval of various telecommunications standards in order to help them build and design new telecommunications systems. So if you're an electronic engineer that's interested or involved in telecommunications, then that might be of interest to you. And then on the right-hand side, we've got a really neat example of RAG being used in agriculture. Here, they're focusing more on geospatial-like data sets, and they're attempting to leverage that information to improve the use of agricultural, tools and ideas. So this is the first example of, sorry, I think I've talked about the wrong one there. I'll get to it in a second. This is the first example of question answering in a regulatory context. This is a pharmaceutical example where, again, they have a set of regulations that developers and companies need to abide by. And those documents are usually quite terse, quite hard to interpret. And so RAG is used here to help the user find the relevant sections of the regulation and also try and answer the question that they're interested in doing. So pharmaceuticals and sort of a regulatory environment. This is the telecommunications spec Q&A example that I talked about earlier. So similar kind of regulatory set of information that's used for question answering. So what was the previous one then? Oh, that was for, yeah, I guess it's kind of the same. This was for more interpreting standards and making sure that the things that you're developing actually conform to those standards. So it's less about regulatory work, it's more about standards work. We've got an example here from the energy industry where some energy companies are attempting to pull in various sources of energy use data and exposing that to end users in a chat-like manner. So people can ask, why is my energy bill so high? Or what was the reason for this spike on this particular day? And things like that. Attempts to answer questions like that. Another question answering case. And on the right, we've got the first summarization task. This is from a science-based domain, a science-based application. So in the industry of research and science. And here they are summarizing content to help the researchers do their jobs better. Very common use case. There's also examples of people using RAG in educational contexts. So in the education industry, there's obviously lots of chatbot focused conversational-like examples out there, but this one in particular leveraged retrieval to incorporate curricula and other sources of information that was important to that particular person's course. And then on the right-hand side, we've got an example from the construction industry. This was an example where the tool would generate daily reports based upon the ingestion of various parts of various bits of data that are coming from within the construction process. I'm going to keep going. There's more industries. There's lots of industries in the world. On the left-hand side, we've got an example from the sports industry. Here, they're integrating with various sport metrics and statistics APIs, and they're leveraging an LLM to ask questions like, what happened on a particular date for a particular player. Example here of how many cards did Messi get in a specific season. And then on the right-hand side, we've got another kind of geospatial application like before, like the agriculture one. This is from the real estate industry. And here they are using geospatial data, but it's a bit broader. It's pulling in information from a variety of sources, but storing them in a geospatial format so that you can do question answering on a geospatial level, like asking, like, what are the most popular neighborhoods for under 20s and things like that. All right, so let me just pause there actually just for a second before I move on. So what I was trying to do there, I know is a really quick run through. I was trying to demonstrate that there are a wide variety of both use cases and industries that RAG could be applied to. So just to recap what RAG is again, because I know I kind of dived in there. RAG is the use of a retrieval mechanism in order to improve the context going into a large language model. So basically retrieve some data from some data source, put it inside the context window, the prompt of the LLM, ask a question about that data, and then receive a result. It's a very common pattern, and there's obviously more advanced kind of architectures that improve upon that process. Talked about that in a previous talk if you're interested in that. And where the goal really is to leverage all of those data sources to do a particular job. So this is just a big list of all of the different industries where you could imagine getting data from various sources and asking questions of it. I know that a lot of these examples used question answering. They had a use case of question answering, but I promise you there are more. It's just that question answering is the number one use case. So moving on now, the common tasks that I found throughout all of my research, and as you can imagine, question answering was the number one. The number two, however, was summarization. Summarization using an LLM to summarize the data that it has received in human-friendly language is also a very common tool, especially when that data is somewhat more harder to interpret, especially if it's like highly numeric or there's lots of it, especially like for the geospatial data there. Like obviously you can interpret it quite well when it's viewed as a map, but you still need like another way of exposing what that map is describing via text. And so they're really leveraging the power of the various language models there to do that. Quite a few applications were simply a mechanism for communicating with a machine for various purposes. So the educational example was a good example of that. Basically, you have a curriculum that you are trying to teach. The LLM's responsible for using that curriculum and attempting to teach the people involved. There may be a range or there may be a separate repository of materials that the LLM can take its inputs from. But fundamentally, it is the LLM that is conversing with a human in order to achieve a task. Another kind of common use case, even though it's kind of less talked about actually, I think it's less talked about in the literature because it's probably not as much, it's not as novel or as interesting to researchers to talk about this, but I see LLMs being used for a lot of traditional machine learning tasks, things like classification and recommendations, and even just plain old bog standard search. Actually, interesting story happened to me the other day. So obviously we as an AI agency, one of the key things that we need to keep doing all the time is to try and tell everybody about what we do and allow us to be discovered when people have a need for the skills that we have. And you know, we concentrate a lot on search and search engines and Google and whatever. But I had the first instance of the other day where which one was it? It was one of the LLMs. I can't remember which one it was now. I think it might have been Claude. Yeah, it might have been Claude. Somebody, a prospective client, had asked Claude, like, who should I speak to about a reinforcement learning project that I've got in mind? And the LLM turned around and said, you should speak to Winder AI. They're experts in reinforcement learning and consulting. So people are starting to use LLMs for search, traditional kind of task that is usually handled by a bespoke algorithm. But the same is true for classification. You know, I've seen a lot of people doing sentiment analysis using LLMs, even sort of generic classification of various traditional tasks that were previously achieved with NLP. They're obviously not as robust, but they're certainly a lot quicker to get working. And then generation, that's probably the final sort of broad theme, the broad common task here is based upon a repository of information, generate new content. The media industry is probably the #1 user of this. Well, I mean, media in its broadest term, you know, media in the sense of written words, spoken words, music, video, you know, all of those different mediums. They are attempting to build tools that leverage previous repositories of content to build new stuff, to basically anchor the generation in something that already looks good or works. But there are a couple of interesting tasks that I found that were probably less common. And I don't know if that's just because there's less need for it, potentially. But you know, I still think it's worth talking about. There are a few examples of using RAG to help verify facts effectively, to improve the retrieval process, to ensure that the LLMs are not hallucinating. And as part of the retrieval process, you basically check the generation against the retrieved content to make sure it's factual. So that's the first one. And the second one, there were a few examples of I don't know what I'd like to call reasoning. Basically, the more kind of symbolic and mathematical kind of approaches were attempting to build out retrieval mechanisms that leveraged not just one shot, go and get me some content, but some kind of reason about this content and find evidence for it. This commonly linked to the use of knowledge graphs. Just going to quick check for any comments. Nope, none yet. So another, okay. So I think we've talked about the common so the common tasks kind of are cross-industry, but also cross-modalities as well. So there were lots of examples of like question answering and summarization and conversation and stuff all throughout all media of all industries. So like using not just text, but images, you know, asking questions of images, asking the LLM to generate captions for images, summarization of images, captioning of videos, you know, things like that. So these are all sort of very common tasks throughout all domains and all modalities. But there were a few modalities that kind of stood out as just being a little bit different. And the first one was related to code. So I think that everybody has already seen and is already aware of the generation of code, the summarization or the explanation of code, and also the completion of code. Especially if you're a developer, you probably use this every day now, you're well aware of it. There were a few others though that were quite interesting. The first one was automated program repair. So this is basically combining the act of describing and summarizing with generation in order to find bugs and automatically fix programs without any external oversight. So that was really interesting. Another one was actually generating code in order to run that code in a sandbox. Now, I think OpenAI were probably the most famous people to kind of popularize that. They would, if you started there, I don't think it's kind of exposed like this anymore, but they used to have a data analysis chatbot where you could load up part of ChatGPT and it wrote the code to do some data analysis for you, but then it actually executed that code in a sandbox, in a container or something. People are kind of using the same idea, but now applying it to different things. Like, you know, they're automatically writing SQL and then running the SQL against a database that they found through RAG or something like that. You know, they're kind of chaining all these things together to do more interesting things. And then maybe one of the kind of scary things was, well, not scary, but interesting. It's definitely interesting. It was the use of LLMs now in testing and security. We worked on a project a few years ago now, 3 years ago, I think, 3 or 4, you know, so it was prior to the LLM explosion, where we built an RL based solution to attack web application firewalls, WAFs. The link is there on the slide, excuse me. And the idea there was to, you know, subtly change various queries in order to bypass the firewall. People are doing the same sort of thing now, but with LLMs. And in particular, it's being more applied to less like the proactive kind of offense. It's also being applied to like defensive testing as well. So on the left-hand side there, we had an example of actually on both of them. Sorry, on the bottom of the screen, the bottom right. We've got an example here of people using an LLM to fuzz inputs in a UI in order to try and find combinations that cause the software to break. So fuzzing is a fairly traditional task, and it's been around for some time, but I think it's just become much easier with the advent of generative methods like LLMs. Previously, you had to rely on sort of rules and codes and stuff in order to do the fuzzing. Okay. Databases are being used more and more, as you can imagine. So the first sort of real use cases of RAG involved parsing documents and asking questions of documents, but more and more people are now open to exposing their underlying data structures directly to LLMs. So there were lots of examples of SQL generation and relational database querying, but there were also a remarkable number of use cases which leveraged a graph of some sort, usually in the form of a knowledge graph, but still they were leveraging the graph and traversing across the graph in order to answer questions from the user. In many of these use cases, the knowledge graph was actually used to verify and refine the response of the LLM to ensure truth. And then finally, we've got sort of more generic translation-like tasks, where basically you are writing something in free text, and you want that to be converted to something else, like an API query, or SQL, or anything like that. Anything where there's an interface which is potentially hard for a user to use generally becomes easier to use when you put an LLM in front of it. There were a couple of examples of media-specific examples. I've already mentioned them, actually. So maybe I'll just mention this thing on the right. This is Stable Audio. This is something that we helped Stability AI build. So we built a lot of this product here. And this is a generative, it's principally a generative AI product. It basically uses diffusion in order to create songs. But one of the interesting features that we added later on was the ability to ground the generation in an uploaded MP3. So you could upload a backing track or a vocal track or audio where you've got like some music and then blanks and then some more music, stuff like that. And you could use that, which the model would, retrieve and leverage in its generation process. So that's pretty cool. So some of maybe the more research oriented examples came from sort of the generic kind of like scientific industry. Quite a few people are attempting to leverage LLMs for various kind of like discovery like processes. So discovering new drugs, discovering new medical applications for stuff, discovering new treatments and things. And these are all based upon a big repository of, previous studies, previous experiments and things like that, which are leveraging the LLM to generate new ones. Again, you could also sort of kind of view these as a bit of a translation task. It's probably not offering a huge amount that previous approaches. A lot of these applications aren't massively novel in the sense that they're not discovering new things as much. The main difference is that now they have an interface which talks in normal English language, as opposed to, you know, some sort of gene protein language, which would be impossible for most people to pass. There were quite a few sort of regulatory approaches as well. For similar reasons, actually. The regulations are quite often so terse, so hard to understand, so big, so long. Many people were using LLMs to basically pass that information and use that information in various ways, whether it be question answering, whether it be grounding new experiments, or providing the constraints that new things have to be within, things like that. And verification as well. Quite a few like mathematical approaches here, using LLMs to, again, effectively describe math, but using LLMs to help them solve proofs, build proofs, design proofs, things like that. So that was pretty interesting. Okay, so based upon all of that, all right, so yeah, so we've talked about some example industries. We've talked about the main use cases now. What were the sort of the key themes and challenges that I saw in many of these use cases? So the first one is that the main challenge of all of these problems was the eventual result was only as good as the retriever. You basically need to focus really hard on the performance of the retriever to get good results. If you are retrieving irrelevant or bad things, then you're going to get a poor result in the end. You know, garbage in, garbage out. It basically, you know, it fundamentally demonstrates the challenge that this is still a data-oriented operation, and if you don't have good data to begin with, then you're not going to get good results. I'll touch on that in a second, actually. A surprising number of them used knowledge graphs and graphs in general. I was sort of pleasantly surprised, really. It's one of the technologies that has kind of been on. It's had like a slow burn since as long as I can remember. You know, they were hot in the 90s when the web was, you know, exploding. They were hot in like the late 2000s, early 2010s when graph databases kind of emerged. And yeah, since then they're still not a super hot technology, but they do power a lot of the underlying knowledge of many of the solutions here. Overwhelming number of question answering like use cases. So if you're looking for a use case and question answering is it, just apply it to your specific industry, your specific with an angle that relates to your job. But all of them involve significant plumbing. So yeah, well, it's like any technology, really. Any tech project involves a significant amount of connecting things together to make them work effectively. And it's no different here. A lot of the work was spent on creating the interface to get the data, to query the data, to find the most relevant data, you know, things like that. So we talked about the modalities a little bit here, but there may be a few that I didn't touch upon because I kind of grouped them all together. Audio, image, and video is kind of one of them. They're very similar use cases, but because they're different modalities, they might kind of manifest slightly differently. 3D was an interesting one. I think that's kind of a little bit of an emerging modality, I guess you could call it. Obviously, we've got like augmented reality and VR headsets and stuff now. But the generation of 3D objects is becoming more and more important. And equally, the use of RAG to constrain those generations could potentially be useful in the future as well. Lots of graph applications, science, others. So actually, I'm going to cover the the second to last one first, because I've already mentioned it. It's still fundamentally reliant on the data here. And if you've got bad data in your database or in your repository, then you're going to have challenges. If there's data missing, if it's badly formatted or not clean, then you're going to get worse results than you would if it was clean. So you do still need to invest in cleaning your data somehow. So back to the top again. Many of these solutions were quite complex in terms of the systems that were being designed here were quite complicated. There are lots of areas in which any one of these particular components in the architecture could fail. A lot of them were very research heavy. They're not built for scale or for production use. And so expect to spend quite a lot of time improving the production readiness of anything that you develop, basically. There was quite a lot of time that was spent talking about the noise within a system. So the act of doing retrieval is quite interesting in that you're not guaranteed to get a perfect retrieval every time. It might retrieve the wrong result. It might retrieve something that is vaguely relevant, but not to that particular query. You may get a false positive. It may look like from the content that it's relevant, but it's actually totally irrelevant. And all of the kind of the subtle machine learning type anomalies that you might see in normal data also apply here. But that's not the interesting thing. The interesting thing was there's currently a bit of a debate as to whether that's a good or a bad thing. So it's obvious, you would obviously jump to the idea that this is a bad thing. Noise is bad. You want to retrieve the best thing that you can retrieve that's totally relevant, it's totally on point, provides good context. But actually, many experiments found that if you intentionally added some noise to the system, if you intentionally added a few bad results to the context, it actually helped to improve the response from the final LLM. It's almost like the noise kind of provided a little bit of like a counterfactual maybe to the data so that the LLM could actually generate a better response. So open question. Don't know whether noise is good or bad here. There's also an increasing gap between the LLMs, the generators, and the retrievers themselves. So the LLM is, very capable depending on which one you used, but it's been trained upon a vast amount of very generic public data. Whereas the retrievers, in some cases, are highly specialized. So even think of a non-specialized application like, the retriever is a graph retrieval algorithm. It's pulling something from a knowledge base. The LLMs probably haven't been trained on knowledge bases, on knowledge-based data, or at least the fact that some data comes from a graph, potentially. I don't know, you could argue whether they have or they haven't. But the point is that the domain that the retriever is working in is not the same domain that the generator has been trained upon. So they're kind of talking different languages. And so this gap presents a problem because the retriever is getting something that basically the generator can't understand. Okay, so depends on what domain you're working in, with what data type you're working in. If you're retrieving data that looks more like massive public web-like data, then you can expect that to work better than something esoteric. With retrieval comes an increased size, increased context size. So you're stuffing more and more content into the context window, the prompt of the LLM, in order to get the LLM to see what the retrieval data looks like. And this is either a problem if you're using something with a small context window. It could also be a problem even if you're using a large context window, because the LLM might struggle to pinpoint the data within that vast amount of data. But I don't know, maybe it's also an opportunity. Maybe, the context windows are now increasing all the time. We've got, examples now of LLMs that are able to use context sizes of 200,000 tokens, or, with some methodologies, they say it's even infinite. And so you could argue that actually, rather than a retrieval task anymore, all we need to do is just stuff all of the data into the context window. So it's potential opportunity there. When you come to non-functional requirements, RAG adds an extra complication because you've got another system in there. So latency in particular, or the time to first token as well in particular, is affected in RAG applications because you're waiting for the retrieval system to do what it needs to do to get the right data for the query. So performance could be an issue. And then finally, testing is hard. You know, I saw for all of these for all of the use cases and papers and things that I read, I was taking a look. Start again. Of all of the papers and use cases that I looked at, they kind of either tended towards using the open source LLM data sets for performance measurement, or they tended to say that this application is in use and the performance is good, right? So testing with RAG is potentially quite difficult because you're adding more components to the system. Testing prompts, like just with an LLM, is hard. When you're adding external systems that are feeding non-stationary data into the LLM in order to generate the response is even harder. You know, you've got the supposed non-determinism of LLMs, plus the definite non-determinism of RAG, because you know probably the data is probably changing over time, and also then you've got other models and algorithms that are used within the retrieval parts of the architecture in order to re-rank and change the rankings and things. So there's all these different things that are all having an effect, and it makes testing really, really hard. And on that note, the topic of next week's talk is how to test your LLMs. And really what I want to talk about there is I'm going to touch upon the traditional metrics that are used to demonstrate how powerful an LLM is. But really, I want to delve into the subject of, once you have an LLM, how can you build an application and test an application to make sure it does what it's supposed to do, and then evaluate the performance of that. So it's kind of like a external view of performance. I don't think there's not a lot that's been written about that yet. So hopefully that will be useful to you. That will be next month's webinar. We're going to do that just before the summer break. So in about 3 or 4 weeks time now, you can check on the events page on the Winder AI website. If you're interested in that, then definitely check that out. Okay, final thoughts. Please feel free to ask any questions if you have them now. There is a bit of delay on the stream here, so type it in quickly if you'd like it answered live. If you don't get a chance, then please feel free to check out our website and get in touch with me. I think, let me just flash up my contact details there. Phil@winder.ai, and the website's winder.ai. I'd be more than happy to answer any questions that you've got about this. So just flicking back again, if you have enjoyed this talk or you found it interesting, then you can find more events on our events page, and also subscribe to our newsletter in our blog as well. So not only do I write up these webinars as a blog post, so I'll put all the links in there and stuff. So if you've been interested in any one of these use cases, then definitely check that out because the links will be in there. But also we've got other articles as well that's written by one of my colleagues, and they're really great. Again, more articles about RAG and LLMs and AI in general. So check it out. Hope you like it. And with that, I'll call it a day. Well, actually, I'll just give it just a couple more minutes to see if any questions come in. I've got my glass of iced water here because it's ridiculously hot in the UK at the moment. We're having a bit of a heat wave, so sorry if my skin looks sweaty. Okay, no questions coming in. I'll leave it there. So my name has been Phil Winder. I'm the CEO of Winder.ai. If you need any help with AI in your business, then definitely check out our website, Winder.ai. I look forward to speaking to you again. I'll see you next time. Thanks a lot. Bye-bye.